projects. In this video, we are going to explain about a project titled Identifying of Fake Profiles Across Online Social Networks by Using Neural Network. So now coming to the introduction part, the application of neural networks in identifying fake profiles across online social networks represents a significant advancement in online security and trustworthiness. It empowers social media platforms and online communities to proactively identify and mitigate the impact of fraudulent accounts, thereby enhancing user trust and the overall quality of online interactions. As the digital landscape continues to evolve, the development of sophisticated neural network-based solutions is crucial in the ongoing battle against the proliferation of fake profiles and their associated risks in the realm of online social networks. So now coming to the objective part for the project of neural networks for identifying fake profiles across online social networks serves a range of critical objectives encompassing fraud prevention, user trust, safety, data privacy, and the overall improvement of the online user experience. By achieving these objectives, online social networks can thrive as vibrant and secure communities, fostering genuine interactions and connections among users while mitigating the risk associated with fake profiles. Mitigating cyberbullying and harassment is also a critical aim. Fake profiles are often used for cyberbullying or harassment. Neural networks assist in pinpointing and reporting these malicious actors, creating a safer online safe space where users can express themselves without being subjected to harm or harassment. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE that is 3.7 version is required. So now coming to the methodology part, here first we have upload social network profiles dataset. This step involves acquiring a dataset that contains information about social network profiles. The dataset typically includes various features associated with each profile, such as user information, posting behavior, network connections, and possibly labels indicating whether each profile is genuine or fake. Second, pre-processed dataset. Pre-processing is a critical step in data analysis and machine learning. In this phase, the dataset is cleaned, transformed, and prepared for further analysis. This includes handling missing data, removing outliers, encoding categorical variables, and splitting the data into training and testing sets. Pre-processing ensures that the data set is suitable for training and evaluating machine learning algorithms. Third, run ANN algorithm. Here ANN stands for Artificial Neural Network. In this step, you would train an artificial neural network on the pre-processed dataset. ANNs are a class of machine learning models inspired by the structure and functioning of the human brain. They consist of interconnected neurons and layers and can be used for various tasks, including classification. Fourth, run quantum SVM algorithm. Quantum SVM algorithm, which stands for Quantum Support Vector Machines, are a type of quantum machine learning algorithm. This step suggests that you are applying to QSVM to the same dataset to classify social network profiles as genuine or fake. Quantum algorithms leverage quantum computing principles to perform certain tasks more efficiently than classical algorithms. Fifth, ANN accuracy and loss graph. The training process of the ANN, you typically monitor its performance by tracking metrics such as accuracy and loss. An accuracy graph displays how well the model is performing on the training and testing data over time, while a loss graph shows how the model error is decreasing. Sixth, predict face or genuine profile using ANN. After training the ANN model, you can use it to predict whether a given social network profile is genuine or fake. This is typically done on new or unseen data to evaluate the model's ability to generalize its learning. Seventh, accuracy comparison graph. This step involves comparing the accuracy of the ANN model and the quantum SVM model. An accuracy comparison graph visually illustrates the performance of both models of the same dataset. It provides insights into which algorithm performs better at classifying genuine and fake social network profiles. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing some dataset over here. Another folder named as model. In this we are containing a model over here. And here this main is the Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload social networks profile dataset button to upload the dataset. Here I am selecting dataset over here and click on open button to load the dataset. Here on the screen you can see dataset loaded and displaying few records from dataset, and now click on pre-process dataset button to remove missing values and to split dataset into train and test split. Here we can see dataset contains total 600 records, an application using 480 records for training and 120 records for testing ANN. And now dataset is ready. Now click on run ANN algorithm button to ANN algorithm. So here on this screen you can see that ANN model generated, and now click on ANN accuracy and loss graph button to get the graph. Here in this graph you can see that the x-axis represents the iterations and y-axis represents accuracy and loss graph. So close this graph and now click on run quantum SVM algorithm button over here. So here on this screen you can see that we got here 100% accuracy. So now again click on ANN accuracy and loss graph to see the graph comparison. Here x-axis represents iterations and y-axis represents accuracy and loss graph. So now close this graph and now click on predict fake and genuine profile using ANN button. Now select this test dataset and click on open button. So here you can see that we have given with the values which is showing account details predicted as genuine or fake over here. And now click on accuracy comparison graph button to get the comparison graph. So here x-axis represents algorithm names and here y-axis represents accuracy. And in both algorithms quantum SVM SVC got high accuracy over here. So now just close this graph. So now coming back to the conclusion part, in sum, the utilization of neural networks to identify fake profiles represents a proactive and essential step in the ongoing battle to create safer, more trustworthy and enjoyable online social networks. It underscores the commitment to fostering authentic interactions and ensuring the integrity of digital communities while mitigating the risk posed by fraudulent online activity. Fake profiles often aim to collect personal information from unsuspecting users. By using neural networks to identify and flag such accounts, platforms can safeguard user data, preserving individual privacy and trust in the platform.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.